Welcome everybody. My name is Sybren and I'm a PhD student at the University in Utrecht, and I use Blender as a research tool. Bit about me, I've been using Blender for about a decade now and Python user for about 8 years. I've been programming and drumming since I was 12 years old, and right now I'm doing a PhD in crowd animation. So the animation of virtual characters where they are really close together. Overview of this workshop, I will talk about a little bit about my research, what I'm doing, and therefore I had a problem in my research. My code was a bit buggy, so in order to fix that bug and to find what the bug actually was, I needed to visualize my data, which is what I use Blender for. So in order to understand what we're actually doing, I will talk a little bit about my research. Then we go to creating 3D objects in Blender through Python, and you got some code, we'll code it by hand. If anybody has a laptop with them, just code with me, see if you can make it work. And from there on, we'll just extend, we create an operator, we'll extend that to connect to a database and load all the data on one hand, and on the other hand, we'll work on a user interface that will become more and more complex as well. Well, in the spirit of everything that's been told already, I'm not focusing on usability. This is just my own research stuff, so it has to work for me and nobody else will ever see it except for you guys. Then we'll look at actually loading the stuff from the database and putting everything together into a nice add-on module so you can ship your code to other people or make it available to all your Blender files rather than just the one you were programming in. And we'll have a bit of a discussion about everything. As I said, I work at the University in Utrecht, which is about half an hour by train from here. I work at the Virtual Human Technology Lab on crowd animation, and then especially on densely packed crowds. A lot of crowd simulation systems already exist, but they work for moderately dense crowds where you can still have the freedom to move independent on where you are in the crowd. And what I want to look at is that when the crowd gets dense, your freedom for movement gets restricted and you have to make smaller motions in order to not hit somebody. So this is how many crowd simulation systems work. They have a cylinder for every character. Those cylinders bump into each other. That is the actual simulation part. And once the simulation is done, the characters are drawn inside the circles. So the animation of the characters and the possible motions that they have does not influence the simulation at all. And you also see that the characters don't really bump into each other because the cylinders don't allow them. Or the cylinders are so small that they can bump into each other, but then you'll see that arms and legs will penetrate other people's bodies, and that doesn't really look realistic either. So instead of that, we want to have situations like this. So what I'm doing in order to get something that works better than that one cylinder is to take a little bit of animation, like you see here, one character doing one step. And I take the mesh of that character, I project it down onto the ground plane. I take the union of everything, and then you get that blue shape at the bottom. And that blue shape represents the space that you occupy during that motion, so I call that the occupancy space. And what I want to do is, in that crowd, compare the occupancy space of possible motions with the occupancy space of other characters. So I have to do intersection tests to see what motion is available and what motion will punch somebody in the face. These are examples of what these spaces can look like. So you have a shape like this. It's a polygon of roughly between 100 and 500 points. So doing an intersection test between those two can be quite time-consuming. So instead of that, I use a hierarchy of circles. So first I take the smallest circle that encompasses the entire shape. And if you want to do an intersection test between those two shapes and the circles don't intersect, then you're sure that the shapes don't intersect either. Otherwise, we divide it in two, do the same trick, one circle there, and I just keep going because you can divide those two halves in two halves again, and then you have 4 circles, etc., etc. And then you get a subdivision like this. I stop when the circles are small enough, like 1 centimeter. You're not going to see much more detail in a crowd anyway, so that's fine. And if you visualize that, then you get an image like this, where you have the big circle at the bottom, and then every layer in the hierarchy becomes smaller and more detailed. So this is actually was the end goal of my work in Blender, to be able to generate images like this, and to use a 3D viewport to look around, zoom in, hide certain circles that are not of interest, and focus on others. And I can also do images like this, where you have an intersection test between two shapes, and the orange circles are for the circles that actually intersect each other. So you see that you can compare a relative small subset of all the circles. And this is a bit tricky. The algorithm goes like, okay, if the bottom circles don't intersect, there's no intersection. Otherwise, we'll have to look at the next level. And that is a bit tricky, because sometimes they're a little bit higher in the hierarchy, sometimes they stop a little bit lower, and I made a mistake. And that mistake just showed up in my crowd simulation. And I wanted to find it, but all I didn't have these images back then. All I had was a database of circles, so that's x-coordinate, y-coordinate, radius, and that's it. So it's very difficult to visualize what's going on. So I created some Python code in Blender to help me with that. But before we go there, I want to know a little bit more about you guys. So who of you has experience at all in programming? Great. Programming Python? Good. Blender scripting in Python? Yeah, all right. Another tricky one, linear algebra and coordinate transformations. Excellent, I didn't expect that. That's good, that's good. All right, it's not much. So it doesn't show it exactly, but you get the drift. Please interrupt if anything is unclear, if I'm going too fast or too slow or whatever. If you have any questions, just interrupt. It's a workshop, it's not a 1 hour of me talking. So the coding roughly says, okay, we created a circle mesh. Then we duplicate that a lot, because one of those shapes is about 1,500 circles. So that's why I also didn't want to do it by hand. We're going to create an operator for that. It connects to the user interface and connects to the database. So we need to add a circle, scale it to show the size, and position it, and again and again and again. So first we want to ensure there's only one circle mesh, which we duplicate roughly by using, I think, Alt-D instead of Shift-D. So otherwise you have 1,500 circles, you get 32 vertices per circle, 2 hierarchies if you want to show an intersection test, which roughly comes down to 100,000, roughly, vertices. It's not that much, but we can do with 32. So for each circle, we create an object that shares that one mesh, and we scale and position it. But first we ensure there's one. So now you get to the Python tooltips. I don't know who viewers looked at it and understands them, or who doesn't. But the little thingy that says bpi.ops means this is an operator, and mesh.primitiveCircle add will add a circle. If you don't see them, then they have changed the defaults to what people actually would like, and have turned off show Python tooltips, so you have to turn it on again. And the cool thing about Blender and the scripting interface is that you actually have auto-completion. You press Shift-Tab, or you click on the auto-complete button, and it helps you. And I think this is a really crucial tool, because if you look at Maya there, you can also do Python scripting, but you do not have this auto-completion. So you can't really just start typing and explore the Python world. So let's see how I switch to a different. I want to. Yes, there we go. So, yes, it is, but I have to always on the Mac keyboard find which control or command or whatever I have to find. So we have ops.mesh, and you can see a lot of them. You can do selecting stuff, you can do with primitive stuff, and you see there are circles, cones, cubes. Everything you know from the Shift-A menu is actually in here. And you can call them, but you can also just let it show all the defaults. So default vertices is 32, which is what we want to use, that's fine. But we will have to give it a radius like 0.5. And the tricky thing is that actually this is not entirely true. I don't know if can you guys all read this? It says location is 0, 0, 0. That's not the default. I don't know why this is happening, but if you don't give it a location, it will spawn at the 3D cursor, which is what you would also get when you use it through the menu. But it's a nice thing to know that you do have to provide the coordinates. So if we do this, and it says finished, which means that the operator is done running. And if we go and look here, there you go, there it is. So now we know how to add an object. It's that simple. It's just one line of Python code. You call that, you're done. So we can create a circle now. We can create a clone, link it to the current scene, and set properties. Because if you create a clone object, it adds it to the data of Blender, the internal data set, but it doesn't show up yet. You have to link it to a certain scene. It doesn't automatically go to the current scene. So this is the code. You just say, we clone the base circle, we link it to the scene. And I just forgot I wanted to show you some more code. This is the actual code that creates that base circle. So it's a little bit more than just the adding thing. You import the Blender Python module. I also wanted to have pi. And if you create an object, you can set the layers. And it's a list of 20 booleans. So you have to type, if you wanted to have in layer 1 only, you type true and then 19 times false. So this is a little function I always use to just say, okay, I want it on layer 4, and this will give me a number of times of false, then 1 true, and then the remaining list of falses. Here's the call to the operator. So the base circle that we will always clone will give a radius of 1, because that's easy. Number of vertices. The fill type is n-gon, so you don't get any weird triangles in there and still have this nice disk. Location at 0. And why we do this rotation, I'll show that later on. It has to do with different coordinate transformations needed between my data and Blender. So then we have the circle. It's in the scene, but you don't have a variable in Python yet that will point to it. So you have to go to the context and the scene. In the scene has objects, and the object has a property active, which gives you the active object. And then we can give it a name, and the data, which is the mesh inside the object, we can give that a name as well. And add some materials. It's also, again, go to the user interface, look at the tooltips, see what button you want to press, which is a tooltip. You can copy it to your Python code and you're done. So that's actually quite helpful. And then here you see a little example of how we clone it. Does anyone know? There you go. That way. So you can click Run Script or press Alt-P and it will run. I will remove that one and run this. And there you have your base circle. It's all a bit trivial for now, but I just wanted to show you the really basic thing first before we dive in deeper. So this is all nice and good. Yeah. Okay. Yeah.
When you are cloning the object, you are given the same mesh is used by all the objects.
Yes.
Applied through transformations in space.
Yes. So the object is the thing that that determines the origin of the mesh data. Yes. Yes. And that is actually what you saw in the code. Is here I apply the transformation. I apply the transformation, which means that the rotation of the object gets applied to the mesh data. So it's like pressing Control A and then selecting rotation. So an operator helps us to build a library of accessible things that you can call from other Blender code. And in order to create an operator, we subclass the operator class, we give it an identifier, and we give it a function that's called execute so that it can be executed. And then we can bind it to a user interface button. So I had to figure out a name for an identifier. I stole one from another importer. It said importMesh.ply. So I also named it importMesh.circleHierarchy. And once you have a thing like this with an ID name and a label, then you already have what you need. It will automatically be registered by Blender, and you will get a bpi.ops.importMesh.circleHierarchy, you can call it. It also has some properties which represent the things that you can see in the sidebar that can influence what the operator does exactly. So to load all the hierarchy circles in one hierarchy, we need the database identifier of the top circle, the biggest one. And the execute, it gets a reference to the object it's called on, which is called self, and the context. That context gives you the same thing as we saw earlier, the bpi.context.scene. In this context, you also get a .scene. But because you can pass an explicit context to the operator, you can make it operate on different objects than you actually selected in the scene. I always forget how you do it, but I've used it once or twice, and it can be very useful. Sorry? Okay. Great. What was said for the people in the stream, you can just pass override is and then an dictionary, and it will override the things from the context.
I might be actually wrong about the actual argument. It could be overrides or override.
Okay, it could be overrides or override, but something like that. And it just falls off the screen, but you return a set object with one string in it. Does anybody know why? Blender works with set objects with strings in it, so you have to return either the set with string cancelled if something didn't work. For example, the drop circle ID was not given, or it's 0, and then you say, okay, I'm cancelling, I can't do this. Or you return finished, and there are a few others which I won't go into now. And then you need to register it as well, which is one line at the bottom of your code. And if you check the register box at the bottom of your script window, it will automatically run your code and then see the register line and register everything. So you can make it register your own operator when it starts Blender. And we'll do the same thing for the user interface. So every time you open the file, everything's built up for you. You don't have to go to click all the run script buttons by hand. Yes?
You're going to share these slides with us, or should we take pictures of all of them?
Oh no, I can share the slides, no problem. There is also a few slides in there with the code really small, so it's not for this presentation, but if you want to just have the slides, you also have a copy of all the code. One thing I've been looking for a long time, because I was looking for things like message bogs or log or anything, is how to give feedback in a little pop-up that gives an error message, or when everything is okay at the top information thingy. Like sometimes over here you see something has completed, or it's called report. I had some problem finding it, but I will share it with you now. And again, you'll see the set of one string construct that you pass error when it's an error, and then you will get a pop-up that you can dismiss, and otherwise it will just flash a little info thingy. Let's see, I've got the entire code here. So this is just a simple dummy operator, and I can run it because we need that for the user interface we're going to look at. And here now, bpi.ops.mesh, no, import mesh. And there you go. You have the circle hierarchy with the properties, the integer properties, top circle ID and circle layer number that I added here. You can see that they become parameters for the call to the operator itself. And now if I call it without top circle ID, boom, you get a message. And it knows by magic that you're calling it from the Python console. So you actually see the error in your Python console. If you bind this to the user interface, you see the error in the user interface. Should I go back? So now to the user interface. We've got our operator. We have two ways of testing it. We can pass it a database ID number, and then it should say, okay, everything is good. Or we can pass it a 0, and then it should give us an error message. It's a very trivial thing, but I think it's always good to start in a trivial way so that you know your user interface is actually linking to the correct operator and stuff like that is working. So we need to create a panel, and the panel works pretty much like an operator. So you subclass the corresponding class, you give it some properties, you implement a draw method, and you register the thing, and then it works. And then you get to which properties? Well, that depends on where you would want it to show. I wanted to have it in the window of the story in the world property list. But you can add it to the 3D viewport in the tools section, in the numeric property section. Maybe you're doing stuff with materials, then you can just place it with a certain material. So that's depending on the BL region type, BL space type, and BL context properties. Like this, I want to label it bounding circles hierarchy, and I want it to be in the region type window, then in the properties, and in the world context. No particular reason except there's a little already there, so I just had this space. As research stuff, as long as I can find it again, it's good. We get a draw method, which also gets a context just like an operator, and you draw your stuff there and you register it. Sorry?
Where is Blender Guru?
Andrew. He was getting an interview at the front, so he's not here. So let's take a look. GUI simple. Yes, note to self, I had to run the dummy operator before, so I did. We got the bounding circles panel, and I set the label, the context, everything. And here you get a layout object, which you can call. You can say, okay, I want a new row, I want to split it in two so that you can get a label and an operator button. And this operator button you give, again, that identifier for your own operator. And then I can set, it returns a properties object, then I can set the top circle ID property. So these are again the same integer properties that we saw earlier. And I have one that should work because it has a top circle ID, and one that may not work. So I run this, and you see something happening here. There you go. There it is, the bounding circles hierarchy. So we can import it, and then you see there at the top, it flashes spawning BCH finished, which is the report call we saw earlier. And I can make a mistake, and then it actually pops up with the error message. So now we know that our code is executed by the user interface. And it's actually that simple to hook something up here. So now I want to load my stuff from the database. And Python has built-in support for SQLite. It's a database that uses only one file. You can access it directly. It doesn't require any database server, software, or whatever. So it's really easy to work with. And it has 2 tables. It has one table with an ID for every circle, 2 coordinates, a squared radius because it's slightly easier to work with in some cases. And it has a sub A and sub B, which are the database IDs for the 2 subcircles. And then we have a hierarchies table with an identifier, which identifies the animation snippet the hierarchy was created from. And the top circle ID, which will give us our starting point for loading everything. So now we go to the coordinate transformation thingy. You already saw that we have a center X and center Z. And our tooling is built up from Ogre. And Ogre uses XZ as the ground plane, and the Y vector is going up. And I guess that's because they originated from 2D graphics, where X, Y is the monitor. So then it's natural to, if you add depth, that Z becomes the depth, and then X and Z becomes the ground plane. But Blender, I think it also makes more sense to have X and Y at the bottom, and then Z, the height. But we have to translate between those 2 coordinate systems. So I made this graphic because I was constantly going back and forth between Blender and Ogre and losing my mind. So by the way, who's colorblind, if I may ask? You are. Can you see the difference between red, green, and blue here? Oh. Sorry? Well, there is yellow-blue color blindness. It's very rare, but anyway, the red, green, and blue arrow are X, Y, and Z. So what you see is that you have to do a rotation over the x-axis of 90 degrees, and then we go from Ogre to Blender. Yes. So to create the user interface, we want to list all the hierarchies. So we iterate over the hierarchies table and show the identifier and show a load button, just as we saw before, except that we fill it with an actual database ID, which is this, which is probably too small. And here we go. So this is the Python support for SQLite. You just import one module and you can access your database. And this is a trick to get the absolute path based on the / notation of Blender. So this is relative to the current blend file. I want this bounding hierarchy.SQLite file. Here we have the panel we already know. I connect to the database, which gives me a database object I can use. I will call draw using that database, and finally I close the database connection. And here again, we just give it a label, we add a row, and we execute a SQL statement. Who does not know what this means? It's a select statement, just says give me something from the database. So I say give me for every hierarchy, so from the hierarchies list, give me both the identifier and the top circle ID. And because I want to find everything again, I want to order it by that identifier string. Sorry about that. So I can, in Python, really easy loop over all the results and just say, okay, that database row, for every database row in the results, give me the identifier and the top circle ID. And then I can split the box was a row, I can split it into two parts, 80% for the label and the other 20% for the button. The label has us text the identifier, and I split the row again to put a button in there, which is, again, just the loading of the hierarchy. You can also set a button text. The operator comes with a predefined text. It was the label we defined earlier, but it's a bit long, so I just wanted to have a small button because the identifiers can get quite long. So it's just BCH on the button for bounding circle hierarchy. I set the top circle ID, and this should actually already give us a result. So I run the script, and because it has the same class name and same label, context, everything as the dummy user interface we just ran, it will just simply override everything. So it's very easy. You don't have to unregister or remove the buttons that you already added. You can just change your code, run it again. It will replace whatever was there. And of course, crap, I forgot my database. Sorry about that. Yeah, it's not my laptop. My laptop was for the people that just walked in. My laptop is missing. My bag is gone from the corridor over there, so be careful where you put your stuff. I can see if I can download it really quickly from my Dropbox. Because without the database, so up to now, any questions while I try and fetch my database file? Yes?
How long did it take you to find out all this? Sorry, roughly how long does it take you to find out all the various hooks for driving the Python user interface from Python? Sorry, the Blender user interface from Python.
It took me a bit because not everything is clearly documented in one spot. So I had to Google a bit. There's a wiki. I've got some links on the end of the slides, but there is quite a good explanation of how it works for Python 2.5, which uses the exact same system as 2.6 something. So that helped. It took me a couple of days to get all this running, but by using the Python console, I could check out everything. Yes. Do you know if you go to the help menu, then you get the Python API reference? There you go. And operator cheat sheet. Well, that's good. And then this is also something I think that Brecht was talking about, the interaction between different editors. Because now if I go to help here, operator cheat sheet, it tells me here, see operator list.txt in a text block. So I go here to my code, and there's operator list. Well, that's good. Bless you. And what we see now is that I replace the database connection. I go back to Blender. It re-executes that draw method that we implemented, and immediately it picked up on the new database file, and there we have all the hierarchies in there. So I can click there now. I've got the list. This is a walk straight animation with frame numbers, and we got the buttons. So we got that working. Now all we have to do is go back to the operator again, and instead of saying yay, everything loaded, and nothing else, we actually load the stuff. So what we do is we already know the database ID of the top circle because we've loaded that in the user interface. We clone the base circle for that circle, do the coordinate transformation between Ogre and Blender, and then we go to the subcircles and we just recursively call that method until we're done. So it looks like this. So at the top here, we see the same stuff we've seen before, except it's wrapped in an if. So if base circle already exists in the objects, we just use it, and otherwise we add it. And we move it to layer number 10. And here we have our operator. I needed to do a test. Very specific situations went wrong. So I needed to have a rotation and a translation of one and a rotation and translation of the other, and then you get the problem. So you can combine those two in a matrix and put it in there like that. You can just say, okay, this is a 4x4 matrix, and make it subtype as matrix, and then Blender automatically makes a matrix object for you. So here we go with the execute. If all the print statements will go to the normally hidden console window. And further up, I created an Ogre to Blender matrix, which is just here, a rotation over 19 degrees over the x-axis. It turns out to be that simple. So we connect, we say, okay, load the circle from the database with the given top circle ID, and finally we're done. And then we say, okay, we're actually done. And this load circle says, give me everything from that circle given a certain database ID. We have to square we have to take the square root of the square of the radius we stored. We can clone the circle, link it to the object. Well, you've seen this before. I don't want it to be selected. And you can give it a name. And this way I know that when I click on a certain circle in the 3D viewport, what the database ID was of that circle, and I can find everything back again. So it links back to the database. Yes?
And the execute function, where did you get the top circle ID from?
That's a bit of Blender magic. The top circle ID is one of the properties, and by setting it in the properties object of the user interface, it will automatically be placed in, where you go, here. It becomes an actual property of the object. So we got the circle. Now we only have to place it and scale it. And the location is given by the X and Z coordinates from the database. And the Y coordinate will be the depth of inside that hierarchy, so that you can show multiple levels in the hierarchy on top of each other rather than all being on the ground plane. Because in reality, they're all represented in the plane, of course, but you don't see it as clearly when. So what we do is we got the location. I do everything with matrices because you can just multiply them and then they work in concert. So first I scale, then I translate to the correct location, and then I convert everything from the Ogre coordinate system to the Blender coordinate system. And that makes sure that everything is okay. So this is also the reason why the original base circle was rotated 90 degrees, because it had to be in the Ogre system, because everything we do is in the Ogre coordinate system right until this transformation here. And that gives me a local matrix, and you can just set circle.matrix local equals that matrix. So instead of modifying the rotation properties and the location properties and the scale properties independently, you can just toss everything into one matrix. And the nice thing about that is once you wrap your mind around the whole matrix thing, is that you're absolutely sure what happens first. It always goes from right to left. So you get first the scale, then the translation, and then something else. Otherwise, if you would swap these two around, you would also scale your translation vector, which is not what you want. And the fourth and fifth elements in the database row were the IDs of the subcircles. So if they exist, I say, okay, load a circle from that ID with depth +1. And that's our recursion step. At some point it stops and then we're done. For fun, I just returned a circle. I'm not using that at the moment. Yes?
Do you have accessible for achieving reverse lines of the data? Do you have one column? Do you only have one column? And for your row has a certain variable?
I'm sorry, I don't quite understand.
Connect to your database.
Yes?
You have rows to your database.
Yes?
The data. Multi-column is one column if you want to set the data. Well, what do you have in the data?
I can show you the database, I'm sure. Well, I would show you if I knew where it lived on this Mac. The answer is I've got one row of data for every circle. So it has database ID, the coordinates, and the radius, and the two subcircles IDs. That's one row in the database. Does that answer your question?
Yes, also basically just in this case all the factors where they measure it. Just fix this.
I'm sorry?
What you have data where they measure, where they generate.
So basically, how did I obtain the data? Well, what we have is motion capture data, which I recorded in our motion capture lab. It's just me walking around, and we've got an algorithm that can compare every frame of every animation with every other frame of every other animation. And we have a metric that describes how similar certain frames are. So what we do is we make them completely the same, and then you've got little bits of animation that can transition from one bit of animation to the other because the transition points are actually exactly the same. So these snippets of animation, we filter the long ones out. Sometimes they're 2-3 seconds, which is too long for our use case. So we got from a half or a quarter to a whole second of animations. And that set of animations we use to calculate all the occupancy spaces, calculate the circles, and output those circles into the database. So that's our flow of how we created all the circles. Thank you. Yes. Thank you. Yes. Are we in our group using Blender for any other purpose than crowd simulation? Yes, we are. For example, we have some algorithms that generate new motion based on other motions, and I often export them to check in Blender what they look like. Because our software isn't that good. I mean, we got a lot of specific algorithms in there that are really good, but in Blender I can easily say, okay, I've got that bone in that foot, connect the viewport to it, and I can see exactly what the foot is doing during a walk. And that really helps us a lot. So yeah, we use Blender for all kinds of things, also for visualizing other animations and rendering stuff for presentations. Yes?
I'm sorry if I'm jumping ahead, but are you also going to talk about, or maybe you don't do this in Blender, collision detection?
Am I going to talk about the collision detection itself? I wasn't really planning on it because I'm now only focusing on what I'm doing in Blender, and the collision detection is not part of that. But if you want, we can, of course, talk about it.
So you work it out in different program or systems you have, and you're importing all that data. You're just using something to show what's happening.
So yeah, I use Blender to show me what's happening, because all I had up to the point that I created this extension was a database of numbers. And then it's really difficult to see what's going on and where it's going wrong. So I can, wait, I'm skipping ahead too far. No. So we've got the code, but we haven't seen it in action yet. So we'll just, again, press the run script button. By the way, usually you would store all this in the same file. Just for this presentation purpose, I created one simple version of the operator in one file and the more complex one in the other file. Usually you just have one file you're working on and have the register button clicked so that everything runs automatically. So it's just for this purpose that I don't have that. So I've run the script. So now my operator should have been updated and we should be able to load the shapes. And there we go. In my own laptop, I knew exactly how to handle it. So I even lost my mouse. So I'm working with a touchpad here, so please bear with me. Does anyone know where the home key is on this thing? Or the... Sorry?
Are you wanting to navigate?
Yeah.
Yeah, you can use the three-finger touch with combinations of Shift and Alt, put it middle mouse and hand. Or maybe it's two fingers. I forget.
Ah, there we go. So here we have the hierarchy. It doesn't look that good yet, but if I turn on cycles, there you go. Let's not turn on cycles. There it is. So now we can see that we have the bottom circle there and the two smaller ones. And if you actually have a mouse that you can work with, you can really easily zoom into everything and hide circles, etc. So I think this is a really easy way to work with your Python code. You can just type it in, you run it, and it replaces whatever was in the memory. So we didn't even have to rerun the user interface code. That button just linked to the new code, and it all works. And as a final nice touch, I also store the occupancy space itself, so that number of points polygon as an OBJ file. So we can create another operator that loads that and shows it as the active object. And then what you get is all these circles, which are black, and the nice outline in orange. Let's see. I'm running out of time, so I'm going to skip this because it's basically more of the same thing. What I do want to show is how you create an add-on out of this. So then you just simply put it into a different file, and you add a small dictionary on top. Great. Say you created some nice code and you want to distribute it to your friends or to maybe even the Blender code base. Then this doesn't work, this approach, because this only works in that one file where you type the Python, which is exactly what I needed, because I needed one viewer to show me one database, and that was fine. But if you want to distribute it, you want to create an add-on out of it. So you toss everything into one Python file, or one Python module. You add a BL info dictionary at the top, and you add some register and unregister functions. So the BL info contains the name of the extension, the author's name, version, the Blender version that you tested it on. And there are some guidelines here, hardly readable, but I will make sure that the version that comes online that you can actually read it. It's a URL to the wiki which shows some guidelines on what to put in there, so that you can actually get your extension approved by the Blender coders. Registering and unregistering works by just calling a register function with classes that you define, so the user interface panel, your operators, things like that. Unregister, you can just say, okay, unregister my entire module. And then you can install it by clicking install from file. And you're done. So to recap, what we've seen is we can create mesh objects from Python. We can create operators to easily call our code. We know how to extend the user interface, to how to get data from outside of Blender and pull it in, and how to create an add-on. So I really hope you enjoyed it. This is my workshop. Do we have some time for questions, discussions?
You can go ahead with the questions if you don't mind. We try to start looking up the next computer.
Of course.
Okay, thank you.
Yes. Sorry? Yeah, sure. I got a question. Is it possible to share your slide? Yes, it is. Just come over here. There was a question in the back there.
Yeah, I was just, you were obviously capturing your data from filming crowds. I was wondering whether you'd actually thought about actually animating the view, that you've got all your circles and subcircles, they're moving around, and how you could see the interactions of a real crowd, or had you looked at that? That'd be sort of, don't know if it's useful, but it'd be interesting to look at.
So, if I understand it correctly, do I show these circles while the crowd is moving around?
Yeah. To show, I mean, are you taking snapshots, or you said you filmed crowds?
No, I don't film crowds. I use motion capture data from just one walking person.
Oh, right.
And
okay.
trying to get all the motions in there to animate an entire crowd.
No, I was here.
And
Okay.
that's what I hope for, that I can use data from one person and animate a crowd of 100,000 people from that.
Oh, I see. But, yeah. Interesting to compare it to a real crowd.
So then I'm not going to show the circles, I'm not going to show the occupancy spaces. I do that for debugging, but it will be way too slow to show them while such a big crowd is running. Yeah.
Okay.
Are we ever going to see your actual crowd simulation software as a Blender add-on?
Are we actually going to see the crowd simulation software as a Blender add-on? It would be really cool, and I really hope that I can do that sometime. If there are any animators here, I would love to have a talk with you about a different project that we're looking at to create an add-on for Blender or Maya to animate human characters based on different data sources. So it would be, I would love to talk with you to know what kind of level of detail you want, what kind of level of control that you want, or that you're willing to give up in favor of automation of a system.
Yeah.
But that's a different thing. Any other questions? Okay, then, thank you.
So,
1, 2.